doubly linked list. Each node has a previous and next, a pointer to the previous element and a pointer to the next element and a value. So each one has three things. All right. In a doubly linked list, we keep track of both head and the linked list and tail of the linked list. For a doubly linked list, this is a duplicate. So this is enough for a doubly linked list. Then we keep going. There are a few cases that we need to keep in mind while coding. Zero element case, head and tail both can be modified. Only element case, like one element, head and tail both can be modified. First element, the head can be modified. General case, and the last element, tail, can be modified. Any program which is likely to change a head pointer or tail pointer is to be passed as double pointer, which is pointing to a head or tail pointer. Basic operations of linked list. Basic operations are insert, print, search, delete, reverse. These 5 basic operations. For any linked list, there are only 3 cases, 0 elements. 1 element, and generally. For double linked list, we have a few more things. The null values, head and tail, both can be modified. Only element, head and tail, both can be modified. First element, head can be modified. General case, last element, tail can be modified. Here is an example of a class of doubly linked list. We have private and public. There's a struct or structure called node, as usual with all linked lists. We have the value here. Because it's doubly, we have the 2 pointers for the next and for the previous. And we have methods, node, and under the private also we have the head and tail, and we have the size, the linked list size. In the public we have these methods. This is the constructor, this is the size method. Is it empty or not? Return 0 or 1. The peak, add head, remove head, because in linked list we can only add from the edges, from the head or tail. We cannot add from the middle. So this is the node method that takes these arguments, and this is the node that takes just one integer, and they are both here, these node and node methods. And doubly linked list example, right? Size, return the list size. Is empty, return the result, whether it matches 0 or no. If the size is 0, then it returns 1, like yes, it's empty. The peak if it's empty, throw this exception, empty list exception. Insert at head. This is the figure. It's very similar to the single linked list, and here's how to add. Yeah, the head here, right? Tail and head of them. Yeah. Insert in double linked list is same as insert in single linked list. Create a node, assign null to previous pointer of the node. So create a node. Here's a new node. Because it's a pointer, we use equal and new node, and we call this, right? And we put null pointers as a default at the beginning. If the size of the list is empty, then the tail equals the head and equals the new node. Otherwise, if it's not empty, then we use the previous. So the previous equals to the new node because it will be at the beginning. And the next of the new node will be the head. And the head will be the new node, and we increase the size by 1. Create a node and assign null to previous pointer of the node. If the list is empty, then tail and head will point to the new node. If the list is not empty, then previous of head will point to the new node, and next of new node will point to the head. Next of new node will point to the head. Previous of the head will point to the new node, to make it like point to the forward and backward, right? Then head will be modified to point to the new node. Head will be modified to point to the new node. Right? And this is we just covered how to insert at the head. Add head. To add a tail, here's add tail. We do this. Right? And here's the analysis. Remove head. Remove the first element. We use this C++ method. And here's the analysis. Delete a node given its value. If we have the value of the node and we would like to delete it, like it's in the middle, for example. So here's the linked list or the double linked list, and we would like to remove the middle one, the A2. So we just connect this next to this previous, right? And remove, delete the middle one and decrease the list size by 1, right? Okay, we point this to that and this to this. So the next of I1 will point to this pointer, and the previous of A3 will point to the next of A1. And here's a remove node if we have the value, right? Here we go. Search list. We compare the past key to the value, and we use the while to go from the beginning of the linked list to the end. Free list to delete the current and keep going. We need to traverse the list and free each node one by one. Finally, head and tail pointers point to null PTR. All right. Print list, we just use the while loop and we use the cout and always the value, and then we next and print the value, and we go next and we print the value until we reach the end, which is the null PTR of the tail of the linked list. And the reverse list, we just create a new one. So we have the current node pointer and the temp node. And the analysis traverse the list, swap the next and previous, then traverse to the direction previous that was next before the swap. If you, okay, so we go, all right, if you reach the end of the linked list, then set head and tail. Set head and tail if we reach the end. Previous equals null, okay. Copy list reversed. Copy list reversed. This is the function. Just keep adding head. All right. Create a doubly linked list. One, we call it doubly linked list, DLL. Traverse the list and copy the values of the nodes into another list by calling add head. So this is to copy reversed. To copy it as is, we just add to the tail, right? Instead of add head, we add tail. Copy list, we just add tail. Here we go. And sorted insert. All right, so we would like to insert in a sorted way. Sorted insert, so we don't really insert unless we reach the value is less than or equal the value. It depends on whether we want it to be ascending or descending, right? So we insert it based on this case. All right, here is the, so it's not null, and the current next value, and yeah, just like that, is greater than the value. At the end, all other at the beginning. So we have three situations. If it's at the beginning, do this. If it's at the end, do that. Otherwise, all other, do this. And if we would like to remove duplicates from doubly linked list, we use this function here to remove the duplicates. And we do this. Consider the list as sorted. We assume it's sorted, and we remove the duplicates by when the value of the current and the value of the current next. Current next and the value compared with the current and the value. If they match, if they are equal, then we just delete. We use the delete. Remove duplicate is same as single linked list case. Head can never modify, only the tail can modify when the last node is removed. And in the next video, we'll talk about circular linked list.